The question we are solving now belongs to test series 7. It is of control system subject. In specific, it belongs to frequency domain analysis using Nyquist plot. As per the question, the open loop transfer function of a unity negative feedback control system is given as g of s multiplied by h of s is equal to 1 by s plus 1 whole cube. We need to find the possible gain margin of the control system in dB. For getting the possible gain margin of the control system, let us substitute S is equal to j omega to get g of j omega multiplied by h of j omega is equal to 1 by 1 plus j omega whole cube. Now let us multiply and divide it by 1 minus j omega whole cube. We know that 1 plus j omega multiplied by 1 minus j omega is equal to 1 plus omega square. So the denominator gets simplified as 1 plus omega square whole cube. And the numerator, that is 1 minus j omega whole cube, can be expanded as 1 minus 3 omega square minus j multiplied by omega cube minus 3 omega. We know that for finding the gain margin of the control system, imaginary part of the g of j omega multiplied by h of j omega should be equated to 0. This is mainly to find the phase crossover frequency. Upon doing the same, we see that the phase crossover frequency is either 0 or root 3 radians per second. So, upon considering the phase crossover frequency of root 3 radians per second, we see that gain margin Gm is equal to 20 log 10 1 by apps of g of j omega p multiplied by h of j omega p. This can further be simplified as 20 log 10 20 log 10 1 by 1 plus j root 3 whole cube, and here we need to consider the apps of the denominator, and this upon simplifying becomes as 20 log 10 8 dB. From this we see that the gain margin of the given control system is 20 log 10 8 dB. Hence the correct option which represents a gain margin of the given control system is A.